Okay, guys, so we're going to take some quick C notes on weather maps. Again, the main focus of tonight's C notes are to focus on the types of fronts and the different types of air pressure. Most of the other stuff should be reviewed, so I should be able to go pretty fast. All right, so of course, when you talk about weather, we have to talk about the jet stream. Now, the jet stream is this river of very fast moving air that is extremely high in the atmosphere that pushes fronts and controls our other weather patterns. The jet stream, as you can see from the picture, does move from the west to the east, and it's called the jet stream because, jets do actually fly in that high level. So, planes that are traveling to the east actually tend to travel faster than when they're heading to the west and going against the flow of the jet stream. But mainly, it is what controls our weather patterns. And sometimes, like if you've ever watched the weather, the jet stream will dip down, bringing cold air, or it'll go up high, bringing up warm air. But fronts do move across America from that usual west to eastern pattern because we are in the westerlies for our global wind patterns. Now, Texas may have fronts that come in from the Gulf, which this does not show in that case. A quick review on air masses. An air mass is a very large body of air that has similar temperature and moisture properties over which it has formed. You have continental or maritime, which is going to determine whether it's dry or moist. And then you have polar and tropical, which is going to determine the temperature. And then extremely cold, we would call Arctic. Okay, so let's get into fronts. The definition of a front is a boundary between two air masses that have different characteristics. So I definitely need you to write that down. There are three types of fronts that we're going to talk about in today's notes, and that is a cold front, a warm front, and a stationary front. So again, a front is just that boundary between two air masses, kind of like a fault is the boundary between two tectonic plates. So let's talk about a cold front. So everybody needs to draw this symbol right here, okay? This is the universal symbol for a cold front. It is blue in color, okay? And it has triangles on it. Now, like I told you today in class, the STAR test is not going to be in color, so you are going to have to recognize these fronts by the way that they look and not just the color. So what does the cold front mean? It means cold, dense air is going to be moving in behind that cold front, and it's going to push that warmer air up and form clouds. Now, we know that when things are cold, they sink, and when they're warm, they rise. And from that ocean currents lab, we know that when things are cold, they have a greater density. So as a cold front is moving in, that cold air that's following behind it is going to be more dense. So it's going to push down at the bottom. So that's what we're going to feel, causing that warm air that it's replacing to rise up. And as that warm air rises up, it's going to cool, condense, and form clouds. So a cold front usually moves very fast, and it causes a lot of showers and actually severe thunderstorms. So the way that you can remember it is the triangles are like cold icicles, and the harsh angles look like lightning that is from the thunderstorm. So that's one of the ways I can remember it. However, done silly way it helps you, that's fine. I'd love to hear them. If it's a good one, I'll steal it. But you just need to remember that a cold front is when cold, dense air is moving in, and it is always associated with showers and thunderstorms. So here's a picture, okay? So as the cold front moves in, it causes this air, warm air, to rise up. And as it rises up, it's going to start to condense and form clouds. And so that is why pretty much right as the cold front's moving in, these showers and thunderstorms are going to accompany it because of that rising moist air. And then here's just a picture. You can clearly see, if I asked you to draw where the cold front boundary line is, you could just see as the clouds are moving in. So this would be warm air. It has not been hit by the cold front. This would be showing behind the cold. So let's talk about a warm front. A warm front is by this symbol right here. It's red, but again, it's semicircles. And a warm front is when warm air is moving behind the warm front and it pushes over the colder air and it's still forming clouds. Now again, density isn't going to change. So the warm air is going to move on top of the cold front and then sink down as it pushes it out of the way. Warm fronts tend to move at a steady pace, and they cause a little bit of drizzle and a little bit of fog as they're pushing down to try to remove that cold front, but it's not going to cause severe thunderstorms like a cold front does. The way I remember a warm front is they look like suns on the horizon. Okay. So here is an illustration showing a warm front. So again, you have the warm front and it's moving in and it's going to go on top because it's less dense. And as it's doing that, the clouds are going to form. And then eventually it'll sink down and the cold front will push out of the way. So you get fog, a little drizzle here and there. And so pretty much after the warm front moves in, it's going to be all nice and humid and sticky like it is in East Texas. And then here's a picture of a warm front. Notice it's very cloudy, very foggy. Okay, stationary front. Now notice right off the bat, let's look at this front. It's like a combination of the cold front and the warm front. Notice that the semicircles are on the same side, pointing the same direction, and the triangles on the same side. Okay, this is a stationary front. And stationary, just like it means, a stationary front occurs when a front stops moving. It is whenever pretty much a cold front and a warm front collide, moving in opposite directions, and one can't overpower the other, so they kind of just stop and hover over an area. So a cold front isn't moving, a warm front isn't moving. Once the front starts moving again, then it will take back over the characteristics of becoming a cold front or a warm front. The air tends to be unsteady and can cause rain and sometimes can even cause showers. So here's a picture of a stationary front. Again, notice the way, and I haven't talked about this yet, but you can always tell which direction a front is moving by the direction that the symbol is pointing. So if you look at the triangles, they're pointing to the right. So that means this cold front is moving from the left to the right. So everything before the cold front has not been exposed to it, so it'll still be warm, where everything behind will be cold. Same with the warm front. The way the circles point is telling you the way that front is moving. So the warm front is moving from the right to the left. So when these two fronts collide, they kind of hit each other and stop. And at that moment, it becomes a stationary front associated with that light wind and a little bit of rain. And then once it would start moving again, this would become back cold and this would come back warm. Okay? It's a tiny little picture, I'm sorry. All right, so I just want to review over the Coriolis effect. We know that the Coriolis effect is when winds bend due to the rotation of the Earth, and we know that everything in the northern hemisphere actually moves in a clockwise pattern because the Earth rotates counterclockwise. So just a little quick review for you. All right, so let's talk about pressure systems. You knew the symbols today in class. So the Coriolis effect does cause wind to bend to the right while moving from an area of high to low pressure. So when we talked about hurricanes today, I told you that wind is always going to move from an area of high pressure to low pressure. And that's going to be consistent throughout the world. So a high pressure front is going to be an H with a circle around it. And high pressure front, so winds do go clockwise. Now, here's my dumb way to remember it. High pressure is happy weather. So H for high pressure, happy weather. Well, what does good, happy weather look like? Pretty much very few clouds, no rain, nice, cool temperatures because the air is more dense. So think about it. It's high pressure because the air above it is very dense, which is causing it to sink. So it's like more things are pushing down on you. That's an area of high pressure. Is it going to be very windy? No, because the wind is moving away from that high pressure. Notice that's why all the tail of the arrows are moving. It's moving away. We tend to normally have high pressure in the winter because it's cooler, that kind of stuff. Low pressure, which is an L and a circle around it, they go counterclockwise. And low pressure, I want you to think about it as lousy weather. So L, lousy weather. Well, what does lousy weather look like? It's lots of clouds, it's dreary, it's rainy, it has warmer air temperatures because it is less dense. So it's like real humid and sticky. And fronts always are associated with low pressure. So put a big star by this that you're writing in your C notes. Fronts always move to a low pressure area. because wind always moves to a low pressure area. So over here, lousy, it's warmer weather. So because it's warmer, it's less dense and it rises, creating an area of lower pressure. So wind is going to move to that direction, bringing all the fronts towards it. So if I ever show you a picture of a map and you see that there's like a low pressure system somewhere, you can bet that there are going to be fronts that you could draw in associated with that area. Okay, so in the southern hemisphere, again, everything is opposite. Low pressure moves clockwise and high pressure moves counterclockwise. So high pressure, happy, cool, clear weather. Low pressure, lousy, warm, rainy, dreary weather. So a way to remember the way the wind blows is high pressure, use a screwdriver to turn a screw into a board. You go clockwise because it's righty-tighty. Low pressure, you use a screwdriver to remove a screw on a board. It's lefty-loosey. So really I'm just trying to stick with the L's over here. So low pressure goes counterclockwise because it's lefty-loosey, LL. And then just the opposite for high pressure. So do draw these pictures here. Okay. So a little bit on wind. Like I said, wind always blows from high to low. The difference in temperature will create a difference in pressure. High pressure will move to low pressure. This is called an isobar map, okay? Isobar are the lines that connect an area of same pressure. So if you think, it kind of looks very similar to a topographic map, which connects areas of equal elevation. This is equal pressure. So as you see over here, this is obviously 996 is a lot lower than 1024, 1028, 1032. This is an area of low pressure. And as you can see, we have a cold front right here that is moving east. And then we have a warm front right here, and then right here it turns into an occluded front, but you don't need to know that. But both fronts are associated with that low pressure. So if I was to ask you, which area of the map would be the windiest? It would be over here, right along south of New York, where over here it's high pressure near the Great Lakes. It wouldn't be windy at all because the wind does blow from an area of high to low. So the closer the lines are to each other, the greater the wind speed. So right here where it's very far apart, it's not going to be very windy. Again, over here where the lines are very close together, it is going to be very windy. So there's a lot of information you could tell based on this map. Also, if I was to ask you where most likely do you think on this picture it would be nice clear skies, it would be over here with the high pressure, happy weather. If I asked you where would it most likely be cloudy and rainy, it would be over here with the lousy low pressure area. So make sure that we can read the maps and interpret the weather. Okay. All right, so this is where I'm going to go ahead and stop. Tomorrow when you come in class, I'll have a bunch of different weather maps for you, and we will practice interpreting them and reading them. Have a good day.